Hey YouTube, welcome to another video. In this episode, I would like to cover what is VLAN and what is the need for VLAN. I will also discuss the VLAN terminologies, how to configure VLANs in a traditional setup, and how Omada as a software-defined network or SDN makes VLANs easier to work with. For example, I will attempt to explain the difference between a VLAN and a subnet, as well as the difference between a native VLAN and a PVID. Before starting with the VLAN definition, let's define what a local area network is and how VLAN can enhance a traditional flat network. So I copied the definition from Wikipedia and I'll put the source link in the description. So a LAN or a local area network is a computer network that interconnects computers within a limited area such as a residence, campus, or building. This is an example of a local area network. In this network, the company is using an unmanaged switch which doesn't support VLAN. And the network itself is defined at the device level. The client devices are located in different rooms, room 101 and room 202. So let's imagine this is the first floor and this is the second floor. However, they are in the same broadcast domain, meaning when one host communicates to another, let's say this marketing computer communicates to another marketing computer, everyone on the broadcast domain can listen and hear the communication. So this type of network is great for small starter network. However, there are at least a couple of concerns with this type of network. The first one is that when the number of hosts increases, it can affect the network performance because of heavy congestion and traffic. So another concern for a flat network is security, even if it's a small network. It is because due to the nature of the architecture of a single broadcast domain, network packets from one department can be captured by another department. Now that you have an idea about some of the challenges of a traditional network, I'm going to share how it's addressed within the traditional network as well. One of the solutions to address concerns about congestion and security is by segmentation. In this diagram, marketing in room 101 have their own network and accounting in room 202 have their own network as well. So both departments doesn't have as much concern about traffic congestion because both departments can expand on their own pace without affecting or impacting one another. There is also a separation of network, so security is also addressed. And once the business policies are clarified on who can access what, a router can be installed to allow for inter-network communication. With the proper configuration, traffic between networks can be allowed as needed. In this diagram, the router have two network interfaces that allows it to connect to both sub-networks. So a subnet is a subnetwork and it is defined in layer 3. So that's the typical and traditional flat network and how you solve those issues. However, moving them from one place to another is not as easy because of the nature of the unmanaged switch. You cannot just configure these unmanaged switches to have different networks. And that's where virtual LAN comes into play. So let's define what a VLAN is. Like the LAN, I also copied an excerpt of the definition of VLAN from Wiki. I'll put the link in the description. A virtual local area network or VLAN is any broadcast domain that is partitioned and isolated in a computer network at the data link layer. In this context, virtual refers to a physical object recreated and altered by additional logic within the local area network. If you remember when I was describing the traditional LAN using an unmanaged switch, that the network or broadcast domain is defined at the device level. For VLANs, it can be defined at the device level or at the port level. It is more granular. Because of this, it allows for having network separation within the same network device. And this opens up a whole lot of possibilities for networking in general. Also, using this diagram, I would like to introduce a few more terms related to VLAN. That is untagged and tagged VLAN ports. In these uplinks in here, These are all untagged VLAN ports, or sometimes called unaccess port, or PVIDs or port VLAN ID. Untagged or access ports is normally assigned to end devices such as PC, servers, cameras, and even phones. For the tagged access ports, they are normally assigned to network devices such as switch, as well as to VLAN-aware devices such as IP phones and servers. Because of VLAN separation, the accounting PC is still not able to directly communicate with the marketing PC. To allow for communication between VLANs or inter-VLAN communication, a layer 3 device is needed. Each of these uplinks here represents a VLAN as well as a dedicated physical uplink. In this diagram, there are only two VLANs. However, in cases where there are many VLANs between network devices, a dedicated physical uplink may not be feasible or viable and requires a trunk. So in this diagram, you can see I have a trunk representation in here. A VLAN trunk is a logical representation of multiple VLANs in a common physical uplink. A trunk VLAN contains a tag and untagged VLAN. In a trunk, an untagged VLAN is called a native VLAN. I also show ROS in here, which stands for router on stick. So router on stick simply means that there is a single physical uplink between a layer 3 device and the switch. I just want to quickly mention in here that a dedicated layer 3 device is not necessarily needed for inter-VLAN routing, because there's also a device called multi-layer switch. A multi-layer switch, as the term implies, have multiple layers. Normally a switch resides in layer 2 and a router resides in layer 3. A multi-layer switch just have a layer 2 and layer 3 functionality. So in this one, you can see that this particular switch doesn't need a dedicated router and it allows for inter-VLAN communication. So these are the terms to remember. LAN or local area network is a group of computers. A flat LAN have one broadcast domain, and LAN with subnets have multiple broadcast domains. A LAN can be created at the switch or router level. The subnet is a subnetwork. It's a logical separation of IP network. It is created at the router level. Subnetting is the process of dividing a network into two or more networks. As for the VLAN, this is the virtual LAN. It allows for logical grouping of computers in different physical locations. It is created at the switch level. There are terms that are very important to learn about VLAN, such as VLAN ID. VLAN ID is a number assigned to a VLAN, and I have here the list of VLAN IDs that you can use. You normally don't have to really worry about it. If you would like to have more knowledge about the VLAN IDs, you can do a quick search, but I put it in here as well. But if you're using VLAN 2 to VLAN 999, everything should be fine. Okay, so let's go to VLAN tag. So VLAN tag is a VLAN ID assigned to a frame. VLAN tagging is the process of assigning a VLAN ID to a network frame. Untagged VLAN means that there is no VLAN ID assigned to a frame. Access port. So it is a switch port that only allows native or untagged VLAN frames. A PVID is a port VLAN ID. It is an access port. Let's move on to the native VLAN. So native VLAN is the VLAN that is not tagged in a VLAN trunk. As I mentioned, VLAN trunk, it is a logical grouping of tagged and non-native VLAN. To demonstrate Omada SDN and VLANs, I have two stack of devices in here. On the left side, I will be using Omada SDN to build the VLANs. And on the right side, I will be using traditional configuration to build the VLANs. All of the devices here are Omada compatible, but I will be using the standalone setup for these two devices. For Omada, I will be using an ER605 for my gateway, an SG2210MP for my switch. Since this is an SDN configuration, I also have an OC300 as my controller. For the traditional configuration, I will be using the device respective management console. I will be using the ER7206 as my gateway, as well as an SG2008 for my switch. For demonstration purposes, I prepared a simple network connectivity and diagram for both Omada-based or SDN-based VLAN configuration versus traditional or standalone VLAN configuration. They are basically the same in terms of the numbers of VLANs. I have an admin VLAN and a home VLAN, and in here I also have an admin VLAN and a home VLAN. The connectivity is very simple. I have an admin PC connected to the controller, and then which is connected to the gateway, and the gateway is connected to the internet. The switch is directly connected to the gateway via a single uplink. The same thing here, except for the absence of the controller. So the admin PC is just directly connected to the switch itself. It can also be connected to the gateway, and that's pretty much it for this setup. Very, very simple setup. I will start with the standalone configuration for creating this network. Then I will create the same network using Omada. If you're looking at the main screen, this is my media PC, this is my admin PC's connectivity. Currently is connected onto the Omada stack. I will be moving my cable from this to the standalone stack. The standalone stack is already connected. It has the wide area network in here, and the switch and the router are connected already as well. So the ER7206 rightmost port, which is a LAN port, is connected to the rightmost port of the SG2008, which is port 8, as you can see here by the LED in here. Okay. And I will move my cable to port 7, and you will see another LED light in here once I do that. So, and now there are 2 LEDs in here. I will now go to the web management console. The basic network that is built into the Omada is 192.168.0 network, and the gateway has a default IP of 192.168.0.1. So this is the interface for my ER7206 gateway. Don't worry about my 1IP. This is not my real 1IP. This is just inside the lab. And to be able for me to create the full network, I also need to log in to the switch. To do that, I need to know its IP address. So let me go to network, and then LAN, and then check the DHCP client. And in here, you can see that my media PC, this PC that I'm using, is currently having an IP address of 192.168.0.101. And the switch, the SG2008, is using 192.168.0.100. So let's verify my IP address. There you go, it's 101. So now I'm going to open a new tab and go to 0.100. So in here alone, you can already see the benefit of the Omada SDN. I only need to do a single login for the Omada controller to configure both my gateway and my switch. In here, I have to make sure that I'm logged into both. Not necessarily at the same time, but I need to be logged into both so that I can compare the configuration and verify the configuration. So imagine doing this on more than one switches. Of course, there are some automations, but still you have to do some manual configuration. Also, I would like to note that one of the great thing about Omada SDN is that you are going to use only one platform, one single UI for every configurations that you're going to make. With the standalone platform, you're going to deal with the web console and the UI of one device, and the same thing with another device. So you can see here, even if they belong to the same family, Omada family, and even if they belong to the same company, TPLINK, the menu, the layout, and everything are still very different with one another. So imagine if you're going to use another brand, make, and model of a different vendor. It's going to look totally different. There's no cohesion at all. Okay, so in here I have to go back to LAN, and you can see I have 192.168.0.1. This is the default network by the TP-Link Omada, and this one is already created, but we need VLAN 10 or home VLAN. So I'm going to create that sub network. I'll just use home, and IP address, I'll just use 192.168.10.1, and I'll use a /24, which is 255.255.255.0. For the mode, I'm just going to use normal, and for the VLAN, I'm just gonna use 10. For DHCP mode, I'll select the DHCP server, and status is enabled. And then for the starting IP, I'll start with the 10.100, and the ending will be 10.254. I leave the rest optional as default, so I'm not going to touch them, and I click OK. There you go. So now the home VLAN interface is properly created. So let me just go to the switch. I need to create VLAN 10 in this switch. So L2 features and then VLAN. And you can see here that there is a default system VLAN in here, which is VLAN 1. The same thing for the gateway. The network devices will always have VLAN ID 1 as the system default. So for the system VLAN, let's review what's currently in the system VLAN 1. You can see here members is from port 1 to port 8 here, and you can see here VLAN ID is 1. I cannot change it. I can change the name, but I cannot change the VLAN ID. And in here you can see there are untagged ports and there are tagged ports section. All ports by default are untagged ports on the switches VLAN 1, and there are no tagged ports in here. So let me click cancel. So now I'm going to click add, so that I'm going to create a new VLAN. The VLAN ID I'm going to use here is 10, and then the VLAN name. So for demonstration, I'll just use home switch. This is a new VLAN, and it's asking me which ports are going to be tagged and which ports are going to be untagged. Since my current uplink between the switch and the gateway is port 8 of my switch and the LAN port on my gateway, I would like port 8 to be tagged. VLAN 1 is already untagged in here. And for demonstration purposes, I will also click 1 as part of the tag, so you can see here how this interface is showing tagged versus untagged ports. And for demonstration purpose, I would like this port 5, to be an untagged port, so that when I use port 5, I will get the IP address from that VLAN 192.168.10 network. Now that that is set up, I'll click create. There you go. So now that's created, you can see here these are the VLAN IDs that I have. I have the default VLAN 1, and this is the newly created one, VLAN 10. The members are port 1, port 5, and port 8. In here, it doesn't really say which one is tagged and untagged. It just says VLAN 10 has ports 1, 5, and 8 as members. VLAN 1 has ports 1 to 8 as members. Now that we have port 5 configured as member of VLAN 10, I will move my media pieces cable from port 7 to port 5. However, even if I move my cable from port 7 to port 5, I will still have the system VLAN IP of 192.168.0 instead of 192.168.10, because I still haven't made the crucial configuration. Let's check my IP address first. So this one should be 192.168.0.101. That's well and good. 192.168.0.1. So I'm pinging the gateway. So if you're looking at the main screen, so in here you will see this is port 7. This is port 7, port 8, port 6, and port 5. Okay. So I'm going to remove my cable here, and you will see that I will get disconnected. So there's only one LED. So this is port 6, port 7, so port 7, port 6, port 5. Okay, so this one is port 5. It's kind of a little bit hard to check. So let's see. So port 8, port 7, port 6, port 5. So the LED in here, you will see there are two gaps in here. Okay. And now I'm in port 5. And you will see on my screen that it's already replying. So if I just go back here again, you will see here that the home switch VLAN 10 in here, the port 5 is already a member. But if we check the IP address, it will still be the system VLAN 192.168.0.101. And that's because I still haven't made that access port to be representing the correct PVID. And to do that, I have to go to port config. And you can see here that port 5 is still using PVID of 1. And this is the reason why I'm getting the system IP instead of the 192.168.10 IP, the IP for the home VLAN. I have to click here, and enter 10, and then hit apply. Now once I hit apply, I'll probably lose connectivity to this interface just because the PVID will be 10, meaning I should be in the network of 192.168.10, but my IP address is still belonging to the system VLAN, which is 192.168.0 network. So I'll click apply. There you go, operation successful. Now I'm pretty sure that this web page is not going to refresh anymore because I have the wrong IP address. So let me go back here, go back here. So once this one shows an error on the ping, meaning the PBID has taken place. There you go, it suddenly stops. There you go, request timed out. But one thing you will notice is that I'm still connected in here. 192.168.0.101. I'm still connected, and if I try to refresh this, you will notice that it's not loading because I actually lost connection in here. And the same thing here, if I do a refresh, nothing's gonna load because my IP is wrong. It's just that Windows didn't know. And what I'm going to do is disable this and re-enable so that I get a new IP. I can unplug and unplug as well, but I decided to do this just for demonstration. And let's check which IP I'm going to get. And you can see that it is now replying again. And this time I should get the correct IP. There you go, 192.168.10.100. And it's replying. And let's see if I can reload this. Wants me to log in again. Before I go to layer 2 pictures, you can see here port 5 is up, okay, and port 8 is up. Those are the two physical uplinks currently connected. And then let's go to layer 2 features. And you can see here on the VLAN and port config, you can see here that the PBID of port 5 is now reflecting the correct one, which is 10. So let me try reload the router. I should be able to reload that now. And wants me to log in as well. Let's do that. So now let me check the network. Let's go to LAN. And let's go to DHCP client list. And you can see here that my media PC appeared twice. One is the previous one, 192.168.0.101. This is when my media PC is connected to VLAN 1. And this one is the current one, which is when I connected to VLAN 10, 192.168.10.100. Let me just go back here to the LAN, and let's go back here. So that's how you create VLANs, and that's how you create the networks. And now let me do that with the Omada controller. So in here, I'm using a 192.168.1 network. The other one, the default network, is 192.168.0, so that I can easily demonstrate that I'm on a different network. So let me ping 1.1 in here, -T. And you will see that it will be request timeout because there is no 1.1 in here. Not unless I transfer my cable to a different switch. So if you're looking at the main screen, I'm going to remove the cable. Here, you can see. And if you watch my previous video, when configuring switches and gateways with the admin PC, I always want to connect directly to the controller. And there you go, you can see that it's replying. And let's see if I can refresh this. I can. And this one, I should be disconnected now, and they will not load anymore. This UI alone is already a big advantage over the traditional way of configuring network devices because you can see all your network devices. So I'm going to create the same network that we create, but this time I'm going to use Omada. This is really very easy to do it in Omada. I'll just have to go to settings and then LAN, and then I'll create a new LAN. I'll just click 10-home, and in here the purpose is interface. The reason why this is interface because this is a sub network. This is being defined on the gateway level, not just on the switch. If I'm only defining it on the switch, I need to create VLAN and then switches only. So this network will be a layer 2 broadcast only VLAN, meaning all traffic will just reside on that switch. Or I can do gateways and switches, meaning I can have a PVID on the router interface, okay, not a sub network, not an IP network, but a PVID configured on the gateway interface. But for now, since this is an IP network, I'll click interface and I'm selecting that. This one is the most important because this is the uplink between the SG2210MP and the ER605. And the VLAN ID will be 10, and then gateway subnet will be 192.168.10.1/24. Update the HCP range so that this one gets populated. I'm just going to start from 100 for demonstration purposes, and I'll click save. And that's pretty much it. My network is created, and it's very easy to assign that 10-home VLAN onto the switch. But let's just go first to the switch profile. So with the switch profile, if you have seen my previous episode, the old profile, it's almost always a trunk profile. The trunk profile will have a native VLAN. In this particular case, it's the system VLAN or the admin VLAN, VLAN 1. And there is a tagged VLAN, which is the VLAN 10. And you can see here, those are existing in here. As for the home profile, currently this one is configured as an access port profile. You can see the native network and the untagged networks are the same. It's 10-home, 10-home. Both of them are representing VLAN 10. And in order for me to configure VLAN 10 on a switch port, so I'll just have to click devices. So I'll click here and I'll click port. Since this is all, VLAN 10 and VLAN 1 are flowing in here. And I'll select port 8 as VLAN home. I'll click apply. I'll select port 7 as admin VLAN and I'll click apply. So I'm going to put my cable to port 8 first, and my IP should be changing to 192.168.10. And if I move my cable to port 7, I'm gonna get my IP from the system VLAN, which is 192.168.1. Let's check that. It's still pinging the .1.1 IP, and this one, if we check my IP, I'm having a 192.168.1.102 IP. Okay, I'm having IP. So if you're looking at the mini screen, I remove my cable and I'm putting it to port 8. There you go. And then I got a reply. Port 8 is 10-home. That's VLAN 10. So if I click here, you can see that I have an IP from VLAN 10, 192.168.10.100, and I'm going to use port 7 now. Oh, I remove it and plug it there. Let's see. Apply. Check the IP. And there you go, I'm back to 1.102. If you're looking at the screen here, this one is called an access port because this particular port only serves admin VLAN. Port 8 is also an access port because this one only serves 10-home VLAN. However, port 1 to port 6, they are all trunk ports. If you need to have a different numbers of VLANs going from one device to another, you have to create your custom trunk profile. So I think that's pretty much it for this video. I hope you like this video. If you like this video, please like and subscribe and post a comment because it helps the algorithm of the YouTube. That's the only way for YouTube to know that you guys are watching my videos. And I really would like to continue doing this and grow my channel. Really, all your comments, likes, and I hope dislike also contributes to getting this video being shown to a much larger audience. Again, thank you for watching my videos. I'll see you on the next one. Thank you and bye-bye.